In this pencast, we're going to be learning about symmetry in geometric solids. So this problem says, state whether the solid has axis symmetry, plane symmetry, both, or neither. So first we need to know these definitions. So a figure has plane symmetry if it can be mapped onto itself Alright, for plane symmetry, you can finish this sentence by if it can be mapped onto itself by a reflection in a plane. For axis symmetry, we say if it can be mapped onto itself by a rotation between 0 degrees and 360 degrees on a line. Alright, so let's look at this first figure. So let's look for axis symmetry first. So what we want to look for is if we draw an axis somewhere on this figure, like say right there, through the center of it, can we rotate it around and get the same figure? So no, that's not going to work. So this doesn't have any axis symmetry, right? So plane symmetry, what we want to look for is if we draw a plane, like let's say we draw a plane right here, cut this figure right here. If we flip this figure over this plane like that, we would end up with the same figure, right? So that means that this figure has plane symmetry, but not axis symmetry. Alright, so this next figure is like a cylindrical prism. So what we have here, if we draw an axis in the center right here, the question is, can we rotate this around between 0 and 360 degrees and get the same figure? So since the base is a circle, the answer is yes. So this has axis symmetry. Alright, so now we need to check for plane symmetry. Other than there, is there anywhere else we could draw planes? So we could draw a plane through the center of this thing, right? Like this. So then we would basically split it into like hemispheres. And if we flipped it over this plane, we would end up with the same figure. So that means we have plane symmetry. Plane symmetry. Actually, we could do the same thing. If we drew a plane in the center of the figure right here, we would also have plane symmetry there. So this figure has both plane and axis symmetry.